What is up, guys? Make sure that if you like this video, hit that like button, subscribe, and turn on notifications. In Unity, there are a couple of ways how we can save our game data. The first way is to use player preferences. And to demonstrate that, I'm simply going to remove this update because we don't need it. We only need the start function. So what we need to do to save data with player preferences is simply type PlayerPrefs dot and set, and voila. So you can either set an integer, a float, or a string. And it goes like this. You have a key value pair. Now I'm gonna use here an integer to demonstrate that because it will be less confusing. A key and a value pair. A key is the name. So set integer, for example, score, that's the key, comma, the value is, let's say, 40. Like this. And this is how we save our game data. Same way goes for the float. So we will say player.prefs or playerprefs.set float. And let's say health, for example. So health, comma, let's say 55. And same goes for the string. So it's playerprefs.set string, but both of these key and value are strings. So this is the key and this is the value. Because they are both strings, that's why I said I'm gonna use an integer for the first demonstration so that it's not confusing. But basically, the first parameter is the key, or let's think of it like a password to retrieve the value. The second parameter is the value. So if I remove these two, and if I go back here, the script is already attached on a game object that I called game manager. And if I hit the play button, this will save that game data. It is saved now. Of course, we did not see anything because it does that behind the scenes. And if we want to retrieve this data, we need to use the key. So in order to get it, we can do something like int score or int s is equal to playerprefs dot get integer, passing here the key. Now the key is this right here. It needs to be the same. So score. The names need to match up. If you typed here lowercase s for the score, and let me remove this point here. So if you typed lowercase s for the score and you type here uppercase, so capital, it will not work. They need to match up. And now we can simply say print, and we can say something like score is plus s. And if I save it and go back into Unity, we will see now in the console when I hit the play button, the score is 40 will be printed, which indeed we see, as you can see right there. So this is how we can save data with player preferences. Now again, this goes the same for a float and for a string. And we can only save these three. So we can save an integer, float, or a string. So this way is not very useful because we only can save three variables. We cannot save a bool, for example, or an object. And this is easily traceable. Basically, we can find it very easily on our, and let me just check it here. It's right here. I've already opened it. You see, on Mac OS, player preferences are stored in library preferences folder. Basically, you can go, you can open that folder, you can edit it. So it's not safe. Which brings a question, in which cases would you use player preferences to save data? Basically, if you want to transfer some data from scene to scene, if you're not using a singleton, so if you're not using some game manager that is a singleton where you can, transfer data with a game object that goes from one scene to another scene, so on and so forth, then you can use player preferences to maybe transfer, I don't know, high score into the next, or your score and health values in the next level of your game. That's one example on top of my head, but there may be other uses how you can use player preferences for saving data. Now, if you want to save your critical game data, for example, the progress of the user who's playing your game, how many levels he has passed, how many money he has in your game, especially if you have some in-app purchase where he needs to purchase money, or he has an option to purchase money. So you don't want him to manipulate these values and cheat in your game, then you will use binary input and output. And how that goes is we need to go back here and create another class. So inside of the project, I'm going to right click and create a C# script, and I'm going to call it player. Let's pretend that we are saving player data. So we're saving player data in terms of his name, his character. Let's say you have an RPG game and the user has created a character and you want to save that character. So you want to save his name, the preferences, the health, the power, so on and so forth. What we need to do is right below using Unity Engine, and we can remove this mono behavior because we're not going to inherit from mono behavior. We're going to type here using system like this. And now that we type this using system, so let me go back up. Now that we type this using system, right below here, we're going to type serialize or serializable, however this is pronounced. Anyways, this will allow this class to be used by binary input and output to encrypt that data. So what I'm going to do here, I'm going to create a private string underscore name, for example, a private int underscore power, and a private float, so float underscore health. And we're going to store these values. And pay attention, they are private. So we need to create getters and setters. And for that, what I'm going to do is I'm going to create here a public string name. And here I'm going to say get, and I'm going to return underscore name like this, and I'm going to also set it. So underscore name is equal value. If you don't know what I'm doing here, then watch my tutorials about C#. It will be more clear. Basically, these private variables cannot be accessed anywhere outside of this class. We need to create public accessors like we did here in order to access them, for example, in this class right here. Because if I create here, for example, let's say player P is equal to new player, I've created a class. If I try to use P, so P dot underscore name, you see, it's not working. You see, only assignment called player name is inaccessible due to its protection level because we set it here to be private. But now since we have this, and I say P dot capital, so it's P dot name, and now I can access it. You see, now I can access and I can say, for example, it's equal to, I don't know, Carl. And now it works. That's why we're using these public accessors. So moving forward, we also have a public int, which is our power, and get, and we're returning that underscore power, and set. We're going to set underscore power is equal to value. And the last thing that we need to do is public float health. And here I'm going to say get and return the health. So return underscore health. And I'm going to set it, and I'm going to say underscore health is equal to the value. And this value will be the value that we provide. So we created a class that we want to use as a data saver, or this is our data that we want to save. So if I go back now in Unity, here on top, I'm going to create a private player. So private player, my player. This is how I'm going to call it. And this is where we are going to retrieve our data. But before we can do any of that, we need to go here and we need to type using system.runtime.serialization.formatters.binary and using system.io, input and output. So these three, using system runtime, serialization formatters binary, and using system.io. So the first thing that we're going to do now is that we're going to save our data. So in order to save our data, we need a file path. So I'm going to create here void save data like this. And the first thing that I'm going to do is create a file stream. So file stream that I'm going to call file is going to be equal to null. Now I'm putting it to be equal to null because if we do something like this, you see the variable file is not declared but never used. Basically, we need to first declare it here to be null. You will see now in a moment why, because then we need to test or to close this file. And if it's not equal to null, we will close it. So now that we have our file, we are going to try here. So we are going to try, and here I'm going to say catch exception E. I will explain everything what is going on here in a second. So in a try and catch block, we're going to do this because when you use a try and catch block, that means what you are doing here can throw an exception. When an exception is thrown in your project, your game can either crash if the exception is too large, or basically some exceptions will crash your game, but other exceptions will allow your game to continue, but you will have an error. So you need to handle that. And in the try clause is where you try to do something that can potentially throw an exception. So we're gonna say here binary formatter, and I'm going to call it BR is equal to new binary formatter, and file is equal to file dot, so it's file capital F dot create, and we're gonna create a file at the application persistent data path and plus, and we're going to add here the data path we want. Now that data path can be slash, let's say mygame.dat, but I'm not gonna do it like this. Instead, what I'm gonna do is I'm going to copy it, and on top here, I'm going to say private string data, so data underscore path is gonna be equal to this, actually in quotes. What am I doing here? Come on, why are you joking with me? Why are you killing me? So yeah, here it is. So now that we saved it like this, which is better, you know, I don't like hard coding things, especially if you want to use this again and in another part of your code, it is better to do it like this. So this file create, it will create this data, or it will create a file at this path. Now, after a moment, we will print this out and see where it is located and open that file. And now that we have created it, we can save our game data. But here for our player, what I'm gonna do is create constructors, two constructors. First, public player. So player like this, an empty constructor. We have it by default, but I'm also going to create a public player. And this constructor is gonna take 3 arguments. It's gonna take a string, string name. It's gonna take an int power and float health. So now I can say underscore name is equal to the name, which is this parameter that we pass here. Underscore power is equal to the power. And our underscore health is equal to the health. Basically, the variable names that we provide here or values will be stored in these private values, and then we can access them via these public accessors. So now here, what we can do is we can say player P is equal to new player. And for the name, I can say warrior, then comma for the power, I can say, I don't know, 67. And for the health, I can say 100. So now we created a player whose name is warrior, 67 for the power and 100 for the health. And now we can simply say BR. Why did I name binary formatter BR? BF. So BF, binary formatter, and we're going to say serialize at this file location, serialize this file. You see this right here. So basically what is it telling it to do is store this data right here at this file location. And now this could potentially throw an exception if that file does not exist, but we have created it. But it can potentially throw an exception. If that exception occurs, you would do something like this. If E exception, so right here, why are you doing enable? If E right here is not equal to null, and now here handle exception. What you can do here, you can warn your player, for example, that the file is not being created and he should try again or something like that. But why is it important for us to use this try and catch block? It is important because you see this file stream, we have opened it. By using this create, we have opened this file path right here, and it is open. After we finish with it, it is really important that we close it because we don't want to have any memory leaks. So we want to prevent that. That might happen or it might not happen, but why should we take a risk? So when you use a try and catch block right here outside of the catch block or here, you can have a finally clause. Now you see this finally clause, what it does, it is called no matter what. How this try and catch block functions is like this. When we enter the try block, we will execute lines of code. So we'll first execute this, then this, then this. If any of these lines of code throw an exception, for example, we execute this, everything is normal. We execute this, but it throws an exception. When that exception occurs, I'm gonna take the highlight tool. So if this right here throws an exception, we automatically skip all the code below it and we jump right here in the exception or in the catch clause to catch that exception. So again, where the exception happens, that is the last line of code that is executed in a try block. Even if we have here below 1 million lines of code, they will not be executed because we catch an exception here. We automatically jump in the catch block to handle that exception. But the finally clause, it needs to be called no matter what. No matter if this right here throws an exception or if it does not throw an exception, the finally clause will be called. And here we are simply going to say if our file is not equal to null that we created on top, we're simply going to say file.close to close that file. Voila, this is what we need to do. And here it is. Now, let me just do one thing. First of all, I'm going to say print, and I'm going to say here datapad is plus, so plus application.persistent datapad plus datapad, like this, so that we print in the console. I'm not yet gonna use here save data. I'm going to put it here, but I'm going to comment it so it will not be executed by the compiler. Instead, I'm going to print it so that we can see where that application persistent datapad is. So if I go here in the console and clear the console, if I hit the play button, pay attention, the datapad is under users, then my name, so I'm gonna go there. So go here, my Mac, then users, then my name. So the library folder is hidden by default. Simply right click it here, show view options and show library folder. And finally, here it is. So again, users, my name, library, application support, not script, but application support, and then default company. So let me just find it here. Default company, saving game data. So saving game data. Here it is. Saving game data, Unity, and this is where the file is, or where the file should be, but we still don't see it because we did not create it. Let's try that out. So if I go back here, and what I'm gonna do is uncomment this save game data, and we don't need this anymore. So I'm gonna save the data by running the game now. So if I click here, play to run the game data should be saved. And if the game data is saved at this location, we should see our file, and voila, here it is. You see now, mygame.dat. Now, we cannot open this. If I open it in text edit, you see what we have here. Assembly, power, help, what is this? You see, we don't even know what this is. We cannot open this, we cannot edit this. You see, if we try to edit, it's not gonna work. It's not gonna work. This data is encrypted, this data is protected, you see? Nothing will work. If I go back now, so if I go back and load the data to display it, so right here, this one is save data, but here we're gonna create void load data. And in our load data, we are gonna do something similar. So we're gonna create our file stream, so stream, and we're going to call it file, and it's gonna be equal to null. Again, we need to repeat basically a similar process. We're gonna have a try and catch clause. So now we have our file stream, we're gonna say try, and here I'm gonna create a binary formatter, BF, which is gonna be equal to new binary formatter, and I'm gonna say file is gonna be equal to file, so capital F dot open, and now we're gonna open the file at the application.persistent datapad plus the datapad, so the same datapad we just gave to save the data. And we're gonna say comma file mode open. So file mode open, and this is going to open our player or the data that we have. Now, in order to extract that data, basically we have the file. So we have the file, which is this one right here. We have the location where the data is, but now we need to extract it from that location. So we need to call our, here you see my player, because that's the data. So we're gonna say my player is gonna be equal to BF deserialize, and we're going to pass here file. Now, as you can see here, it's red. It says cannot implicitly convert type object to player, meaning this will return an object, a general object. So if you don't know what are objects and classes, then watch my C# tutorials. And this will return a general object. It does not know that that object is our player object. So we need to say here as player, not plain, but player. And now this error will go away because it will get us the object as player. And now we have it. And here in our catch clause, exception E, not execute, exception E, handle the exception right here. So you can handle the exception right here. And of course, in our finally clause, we are going to say if our file is not equal to null, then we are simply going to call our file to close. Because again, same reason, we will prevent memory leaks. And if this works, if we load the data, we will have this right here. So we will deserialize. Pay attention here. Here we are serializing, meaning encrypting. So encrypt and save the data. And here we are decrypting and loading data. You see, this is what we are doing. So serialize and deserialize. If I go back here on top and right below, I'm going to call load data. If we have data, then we can do something like this because we are loading, pay attention, we're loading and we're going to put it right here in my player. So if we load, if that works, we can say something like if my player is not equal to null, what we can do is we can say print and we can say player name plus my player.name to get the name, because if you remember here, we saved it like this, warrior 67100. We can also copy this and paste it. This one is going to be player name, player health. And here I'm going to say plus health. And above here, actually, I'm going to say power. And player power, and here player power. So if this right here load data works, it will load the data and it will print these three values, which will be warrior, 67, and 100. So let's go back and test it out. If I go here, and let me clear the console, so clear everything that we currently have. And when I hit the play button, if we load the data, we should see player's health values and everything printed here. So player name warrior, player power 67, player health 100. As you can see here, being printed in the console. So it is printed here, which means we're encrypting and decrypting data to save it and load it back to use it. And this is the right way to save and load your data in Unity, your important data. We talked about player preferences in the beginning, how you can use that. Now this is how you can save data right here, and this is how you can load your important game data. When I say important game data, I mentioned that in the beginning. The progress of the user in your game, how much coins, diamonds, whatever he has during the game, because if you're using in-app purchases to give him an option to purchase items, then you want to store that. You don't want your user to manipulate those values, or you don't want your user to buy, for example, 100 coins and he comes back and he has 0 coins. So in order to prevent that, you can use binary IO to serialize your game data. Fahir here, and I will see you guys in another video. What is up, guys? Make sure that if you like this video, hit that like button, subscribe, and turn on notifications.